2. Greetings and welcome, friends. We are going over the quest. Last night, we were doing some algebra, solving one-step equations, and you might have been able to guess some answers, but I'm not interested in that. I'm interested in, do you know the process? I got to train you to be an algebra ninja. That's right. So here it goes. It says, which property of equality would you use to solve the equation 14x equals 56? Huh. Well, x is being multiplied by 14, right? Do you agree? So how do I undo? What is the inverse operation of multiplying? Division. That's right. That's right. So I would divide both sides. So the answer to this question is the division property of equality. All right, that's why I'm allowed to divide both sides by the same thing without changing its equalness. All right, so here we go. Let's put some of these properties of equality to work. So I've got m plus 9 equals 2. To solve an equation, another way that could be phrased is isolate the variable, get the m by itself. Currently, m is being added by 9. Let's see, Jimmy, what is the opposite of adding 9? Subtracting 9. So I'm going to subtract 9, and I can't just willy-nilly subtract 9 from the left-hand side. I got to do it from both sides. And when I say both sides of the equal sign, okay? Imagine that's kind of the sides that I'm referring to. That, by the way, is called the subtraction property. So subbed prop equality, all right, is why I can do that. And I'd be left with, the 9s cancel out. I'd be left with m. Bring my equal sign down when you're showing your work. Have your equal signs lining up in a column. 2 minus 9, that's going to become more, not more negative. The 9 is more influential. Their signs are different, so it's going to be negative, and 9 minus 2 is 7. So that's what I would end up getting. They asked for a check. You might not have done the checks. I didn't show you too many checks yesterday, and these aren't that interesting to do checks. But to do a check, you would plug this in for the variable. And the question is negative 7 plus 9 equal to 2? Question mark. Is that true? And I get 2 equals 2. That is true blue, because it's in like sky blue right there. You see that? See what I did there? You saw what I did there. Let's see. Cameron, let's have you help me with this next one. Now, r plus negative 8. I'm going to actually rewrite that for a second. I'm going to write that as r minus 8 equals 10. Are you guys cool with that swap? And so Cameron, what is the inverse operation of subtracting 8? Yeah, addition. So I'll add 8 to both sides, showing my work. You could even have multiple colored writing utensils. Be a cool thing. And I get r equals 10 plus 8, or 18. And I could do a check. Is 18 plus a negative 8 or 18 minus 8 10? Yeah, it is. Yeah, it is. And the property that I used, by the way, was the addition property of equality. Okay. Yeah, we'll come back to it. We will. Can do. All right. Ooh, roller coaster madness, apparently, I'm thinking. Is that what this is? Yes. Okay. All right. Here we go. Here's a little word problem, a problem with the words. A discounted amusement park ticket costs $12.95 less than the original price P. So for my variable, P is the original price measured in American dollars, okay? Right. Okay, so let's write an equation. So the equation is going to be based on the fact that I read, that the ticket costs $12.95 less than the price P. So how do I represent that? $12.95 less than, what operation does that sound like? Sounds like subtraction. And am I doing $12.95 minus P or P minus $12.95? $12.95 less than something, so $12.95 is the thing that's being taken away from the original price P. Right? And this is going to equal the discounted ticket. So I could say, right, I could throw in another variable if I wanted. Oh, here we go. Bam. Man, you see that? They done hid some data for me. I was like, wait a minute. This is like a little bit more advanced than we can. I'm going to take this additional piece of information and say that, oh, $44 is equal to the original price minus $12.95. You done see that? They hid some info in the picture. It's a good thing I had that picture there. It just wasn't just for show. Question, comment? That is the discounted price, right? So the discounted price is equal to the original price minus $12.95, right? Yep, right. Yep. Okay. So now let's solve this. VESA, variable equation, solve, and then answer is what we'll do. To solve this, P is being subtracted by $12.95. What would I have to do to both sides to get P by itself? Add $12.95 to both sides. Yep. And let's see, I'm going to flip this at the same time using the symmetric property of equality. So that looks like it's going to be $56.95 was the original price, P. So I solved this, but now I should write an answer, and to write the answer, I'm just going to combine this and this. And I'll say the original price was $56.95. And is that measured in like magic beans? No, it's measured in American dollars, right? And we even see that dollar right there. Okay. Ooh, here we go. All right, keep cruising, Mr. Waddy. Here we go. All right, inverse operations. What is happening to the Q? What operation is going on between the 4 and the Q? Amity. Multiplication. And Amity, if you could be on a roll, what undoes multiplication? Division. So I'm going to divide not just this side by 4, both sides by 4. I'll actually tell you what, I'll show you the Fruit Ninja, right? Those slice out like Fruit Ninja. Pretty great game on the Xbox One using the Kinect. 52 divided by 4 is 13. So I get Q equals 13. And if I wanted to do a check, the question would be, if I plugged 13 in the original equation, is 4 times 13 equal to 52? And I'd get 52 equals 52. For those of you who play cards, you know that there's 13 cards in a suit, 4 suits, 52 cards in a deck. Cha-ching. All right. All right, this one's tricky, friends. Let's see if I can trick somebody. Is this what I do to both sides? No. What operation is going on between the W and the 3? It's division. And what is the inverse operation? Multiplication. I'm going to multiply both sides. And I could multiply both sides by 3, but better yet, does someone have like a one-hit kill, like, whoop-wah? I could multiply both sides by -3. And that'll undo the negative at the same time. Watch how this goes, Fruit Ninja. So one move, combo, whoosh, whoosh, and then those minus signs, whoosh, whoosh, and I get W by itself. Feel free to use that sound effect, by the way, and in any game that you want. You can just rip the audio right out of this video, and you can make your own phone app game called Mr. Waddy Cancels Numbers Out, and you'd go whoosh, whoosh every time. It'd be amazing. So I get W equals -18. So I wanted to point out, don't let that negative symbol fool you. That was not subtraction. That was not, right, minus. That was negative. We were dividing by a -3, and the inverse of dividing by a -3 is multiplying by a -3. All right, last problem. Let's keep cruising here. We got lots to do. Where's my scroll bar? There it is. Oh. All right. All right, let's define a variable here. So the variable, I gave you a clue a while back. I said the variable is usually the question that they're asking. All right. I feel like this is actually weird. Did I? That's weird. Weird. Well, it says, what is the width of the flag? I feel like this is the width, right? Or they're calling that the length because the length is longer than the width. All right, so they're calling this the width. All right, so they call that the dubs. All right, and so the width of the flag is going to be my variable. I get my variable right from the question. The width of the flag is going to be width. W equals width of flag. And what unit should that be measured in? Are we measuring in like fathoms? Are we measuring in like astronomical units? I think feet is a good one. Why do you pick feet? Yeah, because this is measured in feet, and we might as well keep the units the same. Yeah, that's what I'm saying. That's what I'm saying. All right, so now let's see if we can write an equation using this fact. It says the length of an American flag is 1.9 times the width. And then I've also got this piece of information right here. I could call that the length. That's like a fancy cursive L that I tried. So could you combine all of this green information into an equation for me? All right, so the length, 9.5, is means equal. I don't know if you guys knew that. 1.9 times its width. So 1.9 times the width. So that's dubs. All right, so I used my variable. I used the facts that I saw, and I combined it into an equation that is now solvable. All right. Devin, with the save, I don't think we'd be able to do this math in our head, but what is the inverse operation of multiplying by 1.9? Yeah, let's divide both sides by 1.9. And when I do that, I'm going to flip this around. W equals, I'm going to reach for a calculator here. Let's see if I can get some good calculator clacking sound effects on my mic here. So I'm going to go, I wasn't really typing in numbers intentionally there. Let's see, 9.5 divided by 1.9. And I get, oh, mis amigos, it is cinco. W equals 5. Now, if someone asked me this question and I just said, oh, W equals 5, they'd be like, what? I didn't ask you about, where's W? I never even mentioned W. I asked you, what is the width of the flag? So we've got to bring it back to them. The answer, I would say, if W is 5 and W is the width of the flag, I can just pretty much program a computer to write that sentence myself. It would say the width of the flag. The width. It's okay. It's a computer. It's learning. Of the flag is 5. And then Cameron would tell us it ain't just 5. It's 5 what? Feet. All right. And we get an answer. That thing is a thing of beauty. Look at that. All right. Thanks for watching, internet friends. Adios.